This time I have a TASCAM Portastudio. This is a model 424 Mark II. It's a 4-track cassette recorder that you can record individual tracks. It's designed for like home recording, basically. Features 2 speeds, 1 7/8, 3 3/4, and DBX noise reduction. These actually worked quite well, and they were quite popular for home recording. This one's totally dead. Let's see what's wrong with it. First things first, let's check for continuity on the power cord. No, that's me shorting the probes together. Looks to be open. Is there a switch on here? There's got to be a power switch on here somewhere. Probably a master power switch. Where is that? It's on the back there. Okay, it was turned on. So this could be real simple, or it could be a big problem. It could be something as simple as a blown fuse. Let's hope. It could be a little more serious. It may be a blown power transformer. That we won't know until we get into it. But get into this we will. This one's a Portastudio 424. And basically what it is, for those that are not familiar, it's a 4-channel, 4-track multi-track system that would have been used by amateur musicians a lot of times. It's 4 tracks on a cassette. It uses a standard cassette. Most of these will run at double speed. Yes, this one has a speed. Normal 1 7/8 or 3 3/4 IPS. So your C90 cassette, which would normally run 45 minutes on one side, will run at, about 22.5 minutes, something like that. At double speed, but of course much better quality. It has a 4-track head. It's hard to see through there, but has a 4-track head, and you can record each channel individually. So you have 4 inputs, and you got 4 stereo inputs. You got 4 mic line inputs here, and 4 inputs up top here. And you got a stereo input left and right, and a line output left and right, or sub input left and right, line output, monitor outputs to go to your monitor speakers. And then you've got effect 2 send, tape Q out, effect send 1, and then 4 stereo inputs. 5 is a mono input and 7 is a mono input if you're going to use those as inputs, and they would be through this channel here. And there's one knob missing. And you could assign it as a left and right channel, off, or monitor, etc. This is for running into effects board and coming back, for example. Like delay lines and stuff. So you could take an output from here, run it into a delay line, and then bring it back and record it. You can record individual tracks, and while you are recording a second track, you could put it in safe mode. For example, record your first track, and then record your second track or your third track. Never really played around with one, but that will allow you to play back your first track while you're listening to your second track or recording your second track. Play your track 1 and 2 while recording track 3. Play track 1, 2, and 3 while recording track 4. And then of course play them all back and do your mix down. These are level controls for mixing, and I think this is the master output, if I'm not mistaken. Anyway, I've never really used one. I've repaired a simpler one before. This is the first one of these 424s. I forget the other model, but I had one that was similar, but it was the lower down model than this one. And that's the only one I've ever seen. I've only ever seen, this is only the second one of these I've ever seen. We'll put that down on the... Why does it sound like there's something rattling around inside? Listen. That's not good. That's not good. Pull the screws and pull the top off. I think the top comes off on this one. You pull the screws and the top side lifts off, if I'm not mistaken. And again, I could be, because this is only the second one of these I've ever seen. A handful of screws later, and the unit should pop apart. Alright, what do we have in here? We got a bunch of wires. holding these boards together, which need to be unplugged. So these are plugs here that I can undo. And now I can open this up a little more. There's a couple more connectors I have to undo here. One is from the power supply back here. And there's another one. Where is this one going? And what is loose inside here is what I'm curious. There's one more screw. It's a ground wire. Oh, there it is there. It's a ground plug. And this one should just unplug like that. Now I can separate the control board because I don't need that part. Not yet, anyway. What's rattling around in here? Well, I guess we'll just turn it over and see what falls out. Give it a shake. The metal clip has already fallen out. Don't know where that came from. But it was in there and it's metal. And that metal is not good. Oh, what do we got here? Well, that tape deck is loose, yeah. It's not even held in place by screws. I still hear something rattling. But what is it? Another clip. What the hell? Where do these come from? Anyway, two metal clips rattling around inside there probably aren't doing this any good. First things first though, let's check for pop fuses. There's a fuse back here. I have a sneaking suspicion that's on the DC side of the transformer. There's an AC fuse over here. So let's check fuses. Let's hope like hell that it is a fuse that's blown and not the power transformer. I'm not saying it's impossible to find a power transformer. It's probably just a standard 12 volt or 15 volt or whatever it is, but I'd rather it not be the transformer. Okay, fuse wise. That fuse is good. And that fuse is good. And that switch is on. And I have no continuity, so next I have to pull the power transformer and we'll measure the transformer. I have a sneaking suspicion it could be the transformer that has an open winding or a pop thermal cutout. Could be bad. If one of those metal pieces shorted out, for example, and caused the transformer to overheat, it would have popped the thermal cutout, and that opens the winding. So the transformer may not be damaged, it may just be a thermal cutout that's bad on it, but most of these units you can't replace the thermal cutout because it's deep inside the core of the transformer. Some of them they put it on the outside, others they put it right inside the core of the transformer, and if that's the case, you're looking for a new transformer. Also, if the winding itself is shorted, which can happen. If it was overloaded severely, it could have overheated and burned out the transformer. Or it could be the power switch. It could be a number of things. So, haven't lost all hope just yet. Gotta remove all these screws in order to remove the circuit board with the transformer mounted on it, and then we'll go from there. At least the belt looks to be okay. The last one I had a bad belt. In fact, I just recently had someone phone me. The guy I repaired the little guitar amplifier for a couple weeks ago, he phoned me up. He's looking for one of these. He asked me if I knew of anybody who had one for sale, and I said, sorry, I don't. Got two screws down here that are a little more difficult to get out. I should be able to lift the whole transformer at this point. Yes. Just take out this one screw at the back here. It holds the power cord in place. I should be able to lift this assembly out, sort of. And we have to lift out the tape deck. That's interesting that the deck is only held down by one screw. I guess the other ones come in from the back. Okay, now I should be able to lift this out. Almost. Almost. Something else is holding it down. I guess I gotta pull the cover off the switch. Now I can lift this up and turn this over and see that the power transformer itself has no fusing on it. If you look at the power cord comes in right here, goes directly to the transformer. The other side goes to through a switch, and then from the switch, where does it go? There's a jumper here for I guess this is for 120 volts, and there's other windings for other voltages. There's a jumper right there. So if this switch is good and the power cord's good, then it's going to be the transformer. It's pretty easy to determine if it's the transformer too, because I can just measure from the common and see that the transformer is open. So we have a bad transformer on this unit. You see? Mega ohm range. Oh, you guys can't see that. You know, if you can't see it, you don't believe me, but between common and any of the primary windings, it's open. What if I measure between any of the primary windings? You see, we've got continuity there, 5 ohms, 100 ohms, 109 ohms. It's just the common. Could probably make it work by hooking to one of the 240 volt windings, because that one, there's going to be a fuse on this line. Guaranteed there's going to be a thermal cutout on this one. Because normally you'll have a winding, and you'll have one common, and you'll have a tap for 100 volts, a tap for 120, a tap for 220 or 230, and a tap for a 240. So if I went between these two, that would give me a 120 volt winding, because that's a 120 between there and there, and it's a 240 between there and there, so that would be 120 between there and there, if you follow me. And that's 105 ohms, you see. This one here is 96 ohms, and this one here is 5 ohms, because this is the 100 volt tap and a 120 volt tap. So if I were to put a jumper wire from there to there, in theory this thing would turn on, because I'm still creating a 120 volt tap. But there's going to be a thermal fuse on here. Whether it's accessible to be replaced or not, it might be right on this bottom tab here. In fact, it might even be between these two here. These two pins might have the thermal cutout between them. Let's just measure it and see. It's open, but if I measure between there and there, oh, look at that, 25 ohms, 21 ohms, 120 ohms. So this is a winding here as well, but it might be a different tap. It may not be a thermal cutout between there and there. The only way to find out would be to actually pull the transformer, and we'll look for that thermal cutout. So let's pull the transformer out. Either I can replace a thermal cutout on it, or the transformer is going to have to be replaced. Finding this transformer might be a problem though, because it's got multiple secondaries. You see all the different secondaries down here. This is a multiple secondary transformer, so this might be difficult to find. Just saying. But we'll see how it's wired. If that is indeed the thermal cutout there, you might be able to put a new one in underneath the transformer. Sometimes it's on right on the winding itself, other times it's deep inside the core. If I can get to it here, then I can replace it. But the only way to find out, obviously, is to pull the transformer. For big connections like this, I'm not going to use wick. I'm going to use my good old Weller desolder tool. This works quite well for these large connections like this. You just put it over top, and it's vacuum actuated, and hit the button, and it will suck away most of that solder. This works well for large things, but not so good for small things, because it has a tendency, when you're dealing with smaller components, to blow solder all over the board. The problem with this thing is it gets clogged up all the time, and you got to take it apart and clean it. Because like right now, I got 3 connections off. Now I got to open this thing up and clean it out, because it's gummed up with solder, and that's done by basically using this to push, or use something else like a screwdriver, something to push the solder that's clogged up in that that tip. See what I mean? Ouch! And then you jab yourself with it. Use a little Torx bit. That's the downside to these. I wish I could get a pump, but I'm not spending $500, and that's what they go for a half decent one. I'm not spending $500 for something that I would use occasionally. So I'll just deal with this one that gets clogged up every time I use it. It will get the job done, that's for sure. Once I've got most of the solder off with the crude solder pump, I then use the wick just to get off any fragments that remain behind so that I can pull the transformer out without damaging anything else. So the good old pump gets the bulk of the solder out of here, and then I just finish up with the solder wick. Transformer should pull out now just like that, and we can take a look and see that, hey, good, here is the thermal cutout. We can see it right there. So there's my winding. It is, I don't know where it is in this core, but I could probably get another one and just stick it down to the side here, and it would certainly provide protection in the event of a catastrophic failure. But you can see those are the wires that go down to the thermal cutout. So if I just connected these two together, this transformer should work without a thermal cutout. I'd be defeating a safety feature of the transformer, but it still has the power fuse. If something were to short, I think it's still got a fuse, or does it not? No, maybe it doesn't. It doesn't. That's a fuse on the secondary. So if I were to do that, I'd have to put some type of a fuse in here. I think what I'll do is, these typically were around 140 degrees Celsius or so. I could just go get myself a thermal cutout and strap it down to the side of the transformer with some thermal compound on there. That would provide protection in the event of the transformer overheating, or I could just put a small fuse on there as well, and it probably wouldn't be a bad idea to do either. These thermal cutouts typically will protect against overcurrent as well, but they're a pain in the ass because a lot of times they blow for no reason, right? There probably wasn't a short on the transformer. The transformer itself was probably fine. It's just that over time, a lot of times these transformers, you know, they do get a bit warm, and just over time these thermal cutouts will fail. Those metal clips floating around may have shorted something out, which caused an overcurrent, which caused the transformer to heat up. Although typically, if that metal bar shorted, we would expect that the fuses would have blown, and the fuses haven't blown. So I don't think we had an overcurrent situation that caused that cutout to go. I think that probably why the cutout went is just from fatigue, because that's what happens with them. Is thermal cutouts do fail for no other reason as the fact that they're old and they absorb power surges and so forth, and over time, if you know how a thermal cutout is made, it's basically a spring with a little piece of wire sticking out of the spring, and that's soldered down to the end terminal with solder that will melt at a specific temperature, whether it's 240 degrees or 240 Celsius or 300 degrees Celsius or 160 Celsius. Typically they're in Celsius, but it's a very low melt alloy. And when the device itself gets hot enough, it will melt. Now, as I say, there's two different types. There's the resistive type like we find in TVs, which look like a big cement resistor. And I've replaced the thermal cutouts in those before, and that's what it is. It's just a resistor sitting next to a thermal cutout, and it heats up. If it runs too hot, it shuts off. And what happens, a lot of times people put their big screen TV over the fireplace, and they light the fireplace, and the heat from the fireplace heats the TV up as that shuts down. Ones that use in transformers like this, typically the transformer is what's going to provide the heat. Same as in ovens and so forth. The oven is going to provide the heat, and they just have the little thermal cutout sitting next to it. And if it gets over a certain temperature, the solder melts and it dies. So what we can do on these is we can cut this foil or cut this copper so we can get underneath it and strap one underneath there and connect it to the two pins. That will work. I just have to go and find one. So I don't know what the value of this one was. I have the manual for it. It might tell me in the manual. It would typically just list the transformer as a replacement part, but chances are you're not finding a transformer like this today. And even if you could, a transformer like this could be a couple $100 because it's a specialty transformer. It has multiple windings. We can see them here. You can see each one of these has a winding going to it. Now it's got a thicker wire on these ones. These ones are thinner wires, and these ones here are thicker. So it's got 3 different distinct windings. You can see that's one winding. There's another winding here with the center tap, and there's another winding here with the center tap. 3 different voltages are coming off of this transformer. At least 3. Anyway, yeah, I guess we'll have to try to find a thermal cutout. The thermal cutout is inaccessible in this one, as it's under the secondary winding. So there's no way to replace it. I could put an external one on, but you know, most transformers don't even have them. Let's just check the integrity of the transformer and see if it's actually putting out any voltage, first of all. It should be. I've got 120 volts applied across the primary now. Let's just see what we're measuring here. So I've got 3.8 volts there, 7 volts. So this is a low voltage winding, this one. The next winding here has 40 volts across it, right? 12, 3. So this one here is a separate winding. 34 volts across that one, 18. So this is one winding here, but this one's also got a winding across there. Oops, these two have got that's a winding. That's a 40 volt winding there, and that one there is 34 volts. That's a center tap. This one here is 7 volts with the center tap on that. But definitely the transformer is working. And I got this just plugged into my dim bulb tester, so if I were to do something stupid like that, all it would do is just light the light bulb up. Right? So, not drawing any current. Transformer's working. What I might just do on this, because again, a lot of transformers, your AC wall warts, for example, those plug-in transformers that you left plugged into the wall, they didn't have thermal fuses on them, and some of those would get quite hot. They just, if they overheated, the winding itself would just burn out. It would just fuse, because I mean it's a very small gauge wire. So I mean, if there was something catastrophic, the transformer is just going to burn out anyway. It's not going to burn down. Really, there's nothing in here to burn. It's metal, right? It's just going to fuse. If I put a fuse across here on the input, that's going to provide plenty of protection in the event that something catastrophic were to happen, even though the secondaries are already fused anyway. So I'm not getting a transformer for one of these things. Even if they were available, which I highly doubt that they are because of the age of the unit, it's going to be expensive. This isn't a $20 part, right? This is probably a $200 part if you could find one. The last time I changed the transformer on a small, well actually it was an antique radio, it ended up costing over $100 to get a small transformer. Now we had to change it because the transformer was shorted. And that's why I powered this up on the dim bulb tester to make sure that there was no shorts on the primary winding. Because obviously a short on the transformer would overheat it and cause that thermal cutout to go. But that would also make my dim bulb light up, which it didn't. So this isn't drawing any current. So the transformer itself is okay. I'm going to use a very, very fine gauge, just a single strand of wire as my protection fuse that would trip if there was even an amp put through it. I'll use a little strand of wire that will trip even before the transformer would heat up. So I'll just put the transformer back in. Of course, I'll let the guy know what they can do on this. It's completely flush when I solder it down, otherwise when I put the screws in it'll break the solder. I remember when Nakamichi was around, they were really bad at blowing. They had a home stereo, and I must have changed 20 transformers on them. Every single one of them was like $150 for the part. I must have changed 20 of them. People were not happy getting a bill of like $350 to change a transformer on their stereo because they'd overheated it and popped the thermal fuse in it. And then once they went out of business and we could no longer get the transformer, we ended up having to do just this, because it was throw it in the garbage, or we can bypass the internal fuse and just put an external fuse on there, or an external thermal cutout, or just a little short jumper of very, very fine gauge, so that if it were to overload, it would pop that before doing anything else. And I think 100% of the people went that route rather than scrap the unit. And this is some of the things you face when you've got these old vintage pieces of equipment which are no longer supported, is when you have parts that fail that you can't get, you have to try to make things work. In this case, I'm going to use a single strand of wire, just from a jumper wire, like a piece of just copper, and we'll just put it to this pin here. This will act as a fuse in the event that something were to dead short on the primary side. Then this is going to burn and pop. So that fine wire that I just put in, that's not going to pass much power. You can probably barely see it, but there is a fine wire right here. And if anything were to short, that is going to pop before anything else. That's the best we can do when we can't get parts. Again, if someone's wondering what could have caused that thermal cutout to fail, more than likely it was fatigue, just from years of heating and cooling. That's usually what makes them fail, is fatigue. If I power this up, this should light up at this point. Oh, look, it works. Cool. Yes, I am plugged into the dim bulb. There's no current draw. Motor is running. So I guess the next thing is to put the top on it and see if it works. As expected, I spoke to the owner of the unit and he just said go with the fusible link, which is what I've done. I fully expected that he would do that, but I have to give him the option, right? But again, the thermal cutout was dependent on markets, and that's why the transformer actually had that second post on there, was because not every market required it. Like, I don't know about UL, but like CSA required stuff like that, whereas other markets didn't. It all depended on the market it was intended for. And that's why they had the transformer built the way they did. I've actually had this thing also, I just turned it off, but I had it running there for about an hour when I had lunch, and it's not even lukewarm. Actually, you can get the thermal camera on it too if you want to see that. I'll put the thermal camera on so you guys can see. This has been running here for a while. I can turn it back on for that matter, but it's been running for a while. I just shut it off. on the board. Obviously the transformer is going to appear hotter. It's 76.4 degrees Fahrenheit versus 61 for the base temperature. So slightly warm, but not anything that you're going to be concerned about. And this has been running now for, well, over an hour, because I put it on and left it running while I was having lunch, and I just shut it off. So let's just say it's slightly warm, but nothing, you know, if this thing was sitting at 150 or 200 degrees, yeah, then they'll be more concerned. But it's not even, well, it's not even skin temperature. But as you can see, everything's nice and cool on here. Cool as a cucumber, as they say. Yeah, that board's got a little more warmth on it. Well, it's still 65, so everything's nice and cool in here. Screws back in it and give it a test. Okay, let's just try playing a tape. Make sure this is in safe mode. I don't want to erase anything. And play. Left, right. Of course, these ones will give me the reverse direction, because it plays all 4 tracks. And you can pan them back and forth. High speed. Counter reset. Rewind, stop, fast forward, play, pause. Okay, I'm going to say this is working. I'm not even going to bother doing a recording on it because there's no point. I don't even know how to work this thing, for starters. It came in dead. It's working. I have to assume that it records. I guess I could do something. I could record something on here. Let me just grab a blank tape. I could plug my MP3 player, I guess, into it, and I don't know what's on this tape, but I'm sure I can erase it. Line output. Yeah. Yeah, I can record on this tape. We can even record it at the higher speed. Let me just grab my MP3 player. We'll try recording on a couple tracks here. This is an input. I think I can use an input here. Sub input. Mic line inputs. I wonder if this will work. It should. It's that one, I believe. That's a stereo input. I don't even know how this thing works. That's why I say it's it might not even accept anything from that, but we'll see what happens if I hit record. If I hit I don't even know if I'm recording or not. Probably not. That might just be an input. I may have to record through these inputs here. Yeah. Okay, I had a improvise. I need 1/4-inch plugs. So hit record. I'm just recording on one channel now. I think I'm recording. I don't even know how to work this thing. I think I'm recording on the one channel. Let's see what happens here. Did I record? Play. There we go. The other stuff that was there already. Okay, so I recorded one track. I should have done this. See if I do it at normal speed here. So if I went back into record, if I put this into, I guess bus L was it? There we go. Now you can hear the music playing back, but you get the idea. So if you were recording a session, okay, you're recording a new session, the other sessions are still there that were previously recorded. And if I go back to safe, it'll shut it off. And I play this back. Now you hear. Okay, it works. That's all I needed to check, is that it records, and it does. And I recorded it on a junk tape, so I wouldn't expect any type of results, because what is this for a tape? Absolute garbage, but it records, it plays, and it's got power, and it didn't before. So this one's done. Thanks for watching.
I love the view up here. What's this? Shit, not again. Ah, fuck. Goddamn electricity. I'll never win. Happens all the time. That's okay. I'll be okay. I'll fly it off.